This is Team 19947 Nano Trojans Control Award submission for the 2022-2023 season Powerplay. We realized through our designing our robot that to minimize our cycle time and maximize efficiency, we would have to limit our chassis movement, so there would be less room for error. When we assign most movements to one driver, we create a more streamlined and efficient system with fewer opportunities for miscommunication and error. By limiting the number of drivers involved in each cycle, we can improve overall performance and precision while also reducing the risk of mistakes. That leads to our goal, to have 3 ranges of arm movements, X, Y, and Z axis. We have 2 linear slides going up in the Y direction, straight up and down. We have a turret in the X direction and an extending linear slide going back and out in the Z direction. For this, we tuned our PID variables to predict and account for any movement errors, which will bring it back on track. We also used Roadrunner to maximize our speed as well as spline movement. We also incorporated automation into our teleop so that we can prevent human error as best as possible. We have a corresponding automation for scoring on high, medium, or low junctions. We also use Roadrunner and teleop to go to a certain position to gain possession of the cones and another one to score. Initially, we attempted to use TensorFlow to detect shapes on a signal sleeve, but it failed and instead detected the cone. We then decided to use OpenCV because it identifies colors rather than shapes. To accommodate this, we designed the signal sleeve to have 3 different colors and have OpenCV successfully identify it. It needs to be tuned before it can be used along with the PID controller. This is a graph where the target velocity would look like before tuning the PID controller. Now, here's a graph after being tuned to match the target velocity, which are now almost the exact same. Here's an autonomous that uses all of the objects mentioned today. This concludes our Control Award submission. Thank you.